We continue with our discussion on applied financial modeling, and we've already covered the concepts of finding a three asset portfolio risk or standard deviation, return, and we have looked at a recap of the normal distribution. Now we are going to apply this in a mini case, right? So what's that mini case? We have already calculated the portfolio standard deviation for a three asset portfolio in our previous section. Now we want to find out a client, and that's the case, who wants to create a three stock portfolio with certain weightages WA, WB, and WC with the three stocks given. This person wants to maximize the return that is possible. So we have to alter the weightages in a way that the return gets maximized. And the third condition is that the probability of a loss of more than 20% should not be more than 10%, right? So the probability of a loss of more than 20%, which is minus 20%, wherever that comes on this curve, we are saying that this should not be greater than 10%. How do I find this? I can find this using what we just discussed in our previous section, which is the norm dist function. I want to find out for minus 20% using the mean and the standard deviation and a cumulative function. That's what we are trying to solve for, right? So let's actually go to our Excel and create the contours of this particular program and understand that. So we had already kind of looked at this. Now just to kind of make things a little bit easy and readable, we will just remove all these colors, not needed now. We probably need to plug in borders, and we'll do that here as well, right? Now let's move to this side and try and incorporate the suggestions. So we are saying stock, and we will just copy these three names here and the weights there, right? So these are the weights, right? What's the expected, or let's put this as the return? That's the annual return, right? So I'm going to link the annual return that we had calculated, that's here, is equal to this and is equal to this. So we have recorded the annual returns as well, right? If these are the starting weights of the portfolio, if these are the starting weights of the portfolio, can I find average return, right? So average return is either given by this into this, and I do that for all the three. We do that for all the three and add these three, which will give 24.83% average return. Alternatively, I can use a function called sum product, which takes the first array and multiplies with the corresponding numbers of the second array. We have learned these, right? So that gives us the same number, 24.83% is my average return. I can remove this, this is not needed, right? Now we also know let's also do something. Let's put the total sum of these and put some formula here. So we want that if the client gives 100 rupees, that entire 100 rupees is kind of put in these stocks. There is no money lying as cash. That needs to be established as well, correct? And then let's also look at the standard deviation of the portfolio. Now remember, this standard deviation that we see at this point of time is nothing but the daily standard deviation that we get here. So we'll have to annualize it, and to annualize it, what do? We use 2.02% into square root of 250, and that gives the annual standard deviation, right? That's the number we get for the annualized standard deviation, correct? Let's merge and do this. Okay, now I need to find out the possibility of a return or probability of return less than and the equation says minus 20%. How do I solve for this? How do I solve for this? We know the function normdist, and in this x is minus 20%, mean is given here, standard deviation is given here, and I click on cumulative and I say yes. So this number at this point of time is about 7.97%. Right now, if I change the weightages, obviously this number could change. So let's say I change the DLF weightage to something like 40%, and let's reduce this to 15%. You suddenly see that this probability of returns will change and will go above 10%, and we want this number. This number, the client says, should be less than 10%. Right? That's what the client says. The probability of a loss of more than 20% should not be more than 10%. So this has to be less than 10%. That's the condition that will come in. Now we have to try, what do we have to try and find? We have to try and find these weights such that the average return gets maximized and this probability does not cross 10. Now that we have put in all these data points, we also need to remember carefully that once the weights change here, we also want the standard deviation to change, right? So I need to link these weights to the table where they might change, right? And is equals to 45%, and this is equal to 20%, and I can drag it down, right? So if I change this to 30% and I change this to 15 or whatever, 25%, then automatically the standard deviation and the return changes, right? So once we do that, that kind of links everything in place. Now we're going to use something called as the solver. What do we mean by the solver? Solver is available under the data tab here on the right side, right? So you'll see the solver here. If you do not see solver here, you're going to find it in file. Go to Excel options, depending on whatever version you have of Excel. Click on add-ins. Under add-ins, you have to go and click on manage Excel add-ins. Click on go. And in this, you will see the solver add-in. You'll have to enable this. In my case, it's already enabled, but in your case, you'll have to enable this. Once you enable this, click on OK, it'll appear here. So let's open the solver. And you'll typically see a blank value here. I'm going to just change all this. I'm going to delete all of these or reset all and going to kind of start it again. So what was the condition that the client had told us? The client wants a annual return that is the maximized or highest annual return by changing in values of the weights such that this 7.97% does not go above 10%, right? That's what the client wants, right? So you want to maximize the average return cell. That's the max value. So solver allows you to kind of put in what do you want to maximize, minimize, or equate by changing a certain set of variable cells and subject to the constraints. What are the constraints? You can add, change, delete those constraints and then solve for a solution. So we want to maximize this cell K532 by changing what? Changing the weights subject to certain constraints. What are the constraints? The first constraint we find is basically that the total sum has to be equal to 100%. So I can add that constraint. I also want that this cell is less than equal to 10%. The probability is less than equal to 10%, correct? So I can do that. And we find this is how the solver appears. There are like two constraints that are available. And if I click on solve, it'll say solver has found a solution. Now let's look at what the solution is. The solution is that you keep 100% in iShare. That's because DLF and Hindalco give really less returns. And so given their volatilities, you're best off keeping this money in iShares all the time, right? Let's say we don't agree to this and we restore original solutions because the standard deviation is 33% and we may want to kind of reduce that standard deviation, right? So let's just cancel this and click on solver again. And let's say I want to add a condition which says that the standard deviation has to be less than equal to 30%, right? And let's say we click on OK. So we have added a condition that the standard deviation has to go below 30%. If that goes below 30%, we're cool, we're fine, right? So what do? Let's try and solve. And when we solve, it says solver found a solution, right? And solver found a solution that said that if you look on the right hand side, 75% should be in iShare and 25% in Hindalco, and that gives a value, right? So I can probably click on keep this. But my first condition was the client wants to create a 3-stock portfolio. The client does not want a 2-stock portfolio, right? So the client does not want a 2-stock portfolio. So the weight in each of these has to be at the bare minimum some value. So this cannot be 0. This has to be greater than 0, or let's put that this has to be greater than equal to a 5% number. Minimum 5% in any of the stocks. So add, then iShare has to be greater than equal to 5% as well, add, and then Hindalco also has to be greater than equal to 5%. Click on OK, right? So all the conditions have been put in. Let's solve again. Now once we solve, solver again finds a solution and the constraints and optimality conditions are satisfied. Let's keep the solver solutions and understand the solution. What solver does is that probability of return less than minus 20% is 4.64. You get DLF at 5% because that's the minimum weight you want to ascribe given the returns of DLF. iShare at 77, Hindalco at 18%, standard deviation at 30%, right? That's the first case you could solve using an equation like this, right? You could have another case. You could have another case in this case. So let's say case 2, the client wants to create this portfolio, but wants to minimize risk now, right? Wants to minimize risk now. So we are changing the condition a little bit in the solver, right? So what do? Let's go to our Excel file and try and understand this bit. We are changing the condition a little bit. In case 2, we are saying we want to set the standard deviation to the minimum value, right? So obviously this less than 30 condition has to go away. And rest everything, if we keep the same, we want to minimize the standard deviation subject to these constraints. Let's try and solve and see if solver finds a solution. So it says solver found a solution, and that solution says 10% in DLF, 64% in iShare, and 26% in Hindalco, and that gives me these numbers which solve the scenario, right? Let's click on OK. And we can have further constraints that are put up, which is, let's say, if this is less than 10 and everything else is fine, I can change one of these parameters and say that, okay, minimum weightage in a particular stock has to be 15%. Those kind of things could come in. Or I could add a constraint which says, look, I want to minimize subject to the fact that average return remains above 30%, right? So add a constraint that this has to be greater than or equal to, let's say, 30%. And let's say we click on OK and we try and solve this. When we solve this, it could not find a feasible solution, right? So this never goes above 30%, assuming standard deviation is below a certain level. Once you have minimized it, it doesn't solve backwards, right? So it creates a little bit of an issue there. So you cancel it, let it be there. And that's basically your solution to case 2 that you have found in terms of using the solver. So that's how you use the solver in terms of trying and creating weightages. We have learned the concept of variance covariance matrix. We have learned the concept around the functions norm dist, and we have basically used the solver in order to find an optimal weight of this portfolio subject to a certain set of conditions. That's how we use solver. That's it in this particular video. Thank you.